All right, so today it's day 78. Let's solve one more problem. I mean, I already did it, which is this one, the combination sum. We almost done with backtracking. So let's go ahead and redo it again. So in this problem, we're given like a list of nums, and we gotta return like all the combinations that add to that sum, but include like we have to include all of them, and we have like to not take into account duplicates. And within a solution, the same number can be used multiple times. So the way to solve it is just using DFS. My first intuition was to treat every like list as neighbor and perform DFS over each neighbor. So if you choose 2, then you can choose either 2 again, 5, 6, or 9. But if you perform this approach, you realize that you're taking permutations also into account. So we don't want that. So another approach, if you don't want to take permutations into account, is just basically to order the array and choose, because order will also help to pruning, and choose whether to include or not that number. So you can say, I'm going to take the 2, and then when I perform DFS over the next iteration, I'm going to choose not to include the number. So the tree is going to be either I include the candidate or I don't include the candidate, right? So first we create a variable called result. Then we're going to do some sort of backtrack. I don't know the logic, but in the end we're going to like call like a function, right? Backtrack. And we're going to run it over the thing is like at the beginning is gonna start at target, and then I'm gonna pass it taking into account that I choose a candidate. So at the beginning I didn't choose any candidate, so I have target to satisfy, and the first I'm gonna use an index 0, which is gonna be like the window, and I'm gonna also pass like a current path, something like this, and I'm gonna return result. Should I call it the res? Nah, result, it's okay. All right, so now what for the backtrack? Okay, so this is gonna be the remaining, we know, and this is gonna be it's gonna be the start index, so I'm gonna call it start I. This is the list of the current paths. Okay, so now what is the first condition? The first condition is essentially we can imagine that we are at the end of a candidate. We already have a list. The remaining variable is gonna tell us how much like the current sum accounts for. So if this sum is already a target, we can add it like to the result variable, and that's it. And by mutability, we also need to add like a copy, not essentially the same variable, because otherwise there could be an error because it's pointing to the same value or something like this. So we have to say just simply result.append, and we get but if this is equal, so if remaining is equal to 0, so this is equal to target, we're gonna append list of the current path. And if not, let's think about it. If not, we're gonna perform the iterations over the windows that I said. So it's gonna be depending of the start index. I'm gonna say for I in range start index, and the length of candidates. Yeah, this is fixed. And how are we gonna do first? This should appear first. We can directly optimize this problem, because we know that if we take a node, right, and this node choosing to include this node already it's greater than the remaining, it means that any other branch that includes this node at this point it's also going to be greater, hence we don't have to include it. So we can prune the tree at that point. So we can say if if num is greater than remaining, then we can just simply break, right? If not, we are going to choose a candidate. So I'm going to say cur path dot append no, okay, but I'm going to define num is just candidates I. So we append the number, and then once we choose it, we need to perform the backtrack, like by choosing the numbers. I'm gonna say backtrack remaining minus num. Yeah, because if we choose num, then the remaining we have to subtract it. We pass still I because we don't keep forward I, because we can use the same index again, right? And we have to pass also curve path, right? Okay, but now we are at the end of the node, and the issue is that, let's say that we choose a value that was greater than the sum, right? Like we do the backtrack, right? And then we realize that this is not good solution, so we need to pop it from the current path, right? So I just have to say curve path dot pop. Yeah. Let's run it. We have curve path is not defined. We need to do it here inside the for loop. And we have also an error. What could be the error? Let's read the code again. So we are doing result, then we're doing backtrack, remaining, start I, curve path. Okay. Result of the band list, yes. For I in range, start, yes. If none greater than remaining, we break. Yes. We perform backtrack. Curve path. What? No, wait. I'm completely tripping. This backtrack should be called after the function. Yes. But curve path is not defined. I mean, it's gonna be an empty list at the beginning. And what is the problem now? Candidates is not defined. Candidates is not defined. I mean, candidates is nums. And what is the error now? Cannot access a local variable num where it is not associated with the value. Candidates. Let's say solution. Okay, we missed literally, I don't know why did I put it here. Yeah, this was the error. Okay. No candidates id. Wait, why do I still put this? Oh my god, yeah, I forgot to sort it. Yeah, that's really bad. On I indent does not match indentation level. Okay. Let's just fix it. Alright, should be fine now. Cannot access local variable I. It's here. Okay. Yeah. That was it for today.